Hi, I'm going to talk to you today about a new product from QHY, best known for their cameras, CCD CMOS cameras, and the new product is the Astrobar astronomy computer. I've got one here. The first thing you notice is actually the box. The box is one of these really high quality boxes, more often used by Apple and the likes, and inside is the Astrobar computer itself. So this is a full computer. It's a PC. It's a Windows 10 PC, and purpose designed for astronomy for use with your telescope mount. The specifications: it's an Intel Atom processor running at 1.33 gigahertz, and it's got 2 gigabytes of RAM on board. Storage is by way of a 32 gigabyte onboard eMCC storage, but that can be extended using up to 128 gig on an internal microSD or TF card. That does need to be installed when you order it. It's not really a user installable part. It runs off 12 volts, which is useful because that's generally what we've got when we're using telescopes outside. And you'll see that it's got 3 12-volt ports here, and there's actually another one on the other side. They're common together, so you can actually use any one of those ports to power it, and you can then take power for other devices from there. It's got lots of USB ports, which is always very handy. So it's 6 on the side, another 2, so there's 8 USB ports that are usable. One thing that's really quite nice is it's got 2 hardware serial ports, RS-232 ports. They do have specialized connectors that I'll show you soon, but it is nice to have that straight on there so that you don't need to use the USB to serial converters. It does have Wi-Fi, so built-in Wi-Fi and built-in wired Ethernet, so that's gigabit Ethernet as well. There's onboard Bluetooth, and display, if you were to connect the display, is by way of an HDMI socket on the end there. It also has another port, which is a remote power port, so that will allow you to remotely turn this on and off, and I'll talk about that a little bit later. The operating system is Windows 10 Home. It's a 32-bit edition. It's fully licensed. It's a legitimate copy with an OEM license. The unit itself is made out of very sturdy aluminium. It has lots of holes for mounting, so there's lots of options to be able to mount this to your telescope or to your telescope mount. So through holes and threaded holes, so lots and lots of different options there. What I'll do is I will get this connected up, and I'll show you it powered up, and we'll put it through its paces and have a little look at what it can do. So I've hooked up a 12-volt power supply. I've attached the Wi-Fi antenna, HDMI cable, and I've also put a keyboard and mouse USB dongle in there. So let's power it up and see how long it takes to boot. So you'll notice that there's a red light around the power switch. That's quite useful. Obviously red's the best colour. We'll use this at night. Also allows us to see that the unit's powered on and ready, because often, I imagine, most people will use this in what we call a headless mode, so no monitor attached. So it boots up in probably about 35 seconds, 40 seconds, which is pretty good, and straight into the Windows desktop. As delivered, it has ASCOM installed, a Intel remote keyboard utility that I'll show you a little later, and that's pretty much it. I've installed a couple of things on here. One utility that is of note actually is this one here, which is called Astro Computer Control. This allows you to manage the USB ports. One of the challenges of a remote system, particularly if you're using this from inside the house or away from your observatory, is sometimes we do need to disconnect peripherals. We may need to unplug them and plug them back in the case that a camera or something is locked up. This utility, which is quite thoughtful from QHY, It allows us to do just that. It allows us to disconnect a USB port and reconnect it, all without going anywhere near the unit itself. There are 8 USB ports on here, numbered 1 to 8, and the utility also shows all 8, although the numbers, if you can make them out on screen, actually don't match what's on there, I imagine. This is of course a beta test unit. I imagine they'll get fixed up at some point soon. One thing of note is the numbers labeled 7 and 8 here on the screen, which correspond to 1 and 2. They don't actually change the power. This would be where you generally connect your keyboard and mouse, and quite a good idea that those can't be turned on and off. So in order to demonstrate that, I have a USB memory stick here, and we'll just put that in here, and we'll see that it lights up. And as you'd expect, and I get a box with my files on it. If I then turn off this one here, labeled as 3, you can see that the light goes off on the back of the USB stick, and also the file box closes, so that's no longer connected. If I click the button again, the light comes on and the USB stick is connected. So very, very nice for cameras and other peripherals that we might need to restart or disconnect as an observing session goes on. So 2 things that I wanted to check out. One was, how does the unit perform, and what kind of things can I do as a real world test for that. And the other one was, how much power does it draw, because if we're going to be using this on a battery power supply, then we want to know that it's not going to take all the power and we're going to run out our battery halfway through the night. Now the website says that the unit uses 4.5 watts, so I was interested to check that out and have a find out what we measure. So let me just juggle the setup around a little bit, and I'll put a meter on there and we'll see how much current is actually being drawn. So in order to check how much power this unit will use under heavy load, what we can do is run some load testing software. What this will do is stress the CPU and memory of the unit and hopefully push it to its maximum power draw. So I'll go ahead and start this application. And what we'll see down at the bottom of the screen over here, you see that the CPU usage should go up to the top, showing that we're using 100% CPU, and the free memory will start to go down as we're filling the memory up. What we'll also see if we look at the meter is that we're now drawing quite a lot more current, so this is looking just a shade under 1 amp. Now that does mean the 4.5 watt estimate is slightly underestimated. That looks more like 12 watts to me. But then again, this is probably an unrealistic test, because we shouldn't really be running anything that's loading the processor this heavily. If we are, then that's probably something that's best served on a bigger computer. So if we stop the test, we'll see that the power draw goes immediately back down to what we were running before, which is around about 0.3, 0.4 amps. So one other thing I wanted to test was what the performance would be like using something a little real world. So if you just give me a second, I'll get that set up. So for a real world performance test, what I wanted to do was some basic imaging. Because it's cloudy outside, as it has been for much of the year so far, I thought I'd just do this inside. What I've got set up is a QHY 5 camera. It's set in another new QHY product, actually, the mini guide scope, which I'll do a video on when the weather gets a little bit better. I've just got it focused across the office here onto a business card, stuck on the wall, a little bit close for real world use, but in terms of capturing an image, it's pretty realistic. So at full frame, which is 1280 by 960, we're currently capturing at 7.3 frames per second. If I were to change our capture area down to 640 by 480, which is what we'd probably use as realistic for planetary imaging, you can see that we are getting close to 30 frames a second. So that's reasonable performance actually for this little computer for imaging. Most imaging tasks are actually not that resource intensive. If you're looking at capturing CCD images, for example, then really that's just the image download. So fast images for planetary through webcams or little planetary or guide cams like this probably use the most in terms of CPU performance. So that's quite a good test in actual fact, and it's quite a good result. In order to control the Astrobar, obviously you'll need to use some kind of input devices. So I've been using a wireless keyboard and mouse for this demo. There they are on the desk, with a wireless USB dongle. That's not the only way. If you've got this set up and you're using this outside, you may well want to control this directly, but don't have a keyboard and mouse, or it's a little bit cumbersome to carry those around. There is an option that comes pre-installed, and it's called the Intel Remote Keyboard software. So we'll just open this up and we'll get a splash screen that will quickly go away. On my tablet, on my iPad, I've installed the Remote Keyboard app. It's free, Intel Remote Keyboard, and if we just open that app up, that will immediately go and scan the local network looking for any devices that it can connect to. So this is my device here. Now on screen you'll see it's come up with a QR code. So if I hold up my iPad to scan that QR code, now we are connected. So if I move my finger on the screen here, you should be able to make out on the computer display, on the Astrobar display, that the mouse is working. So we can also use the keyboard as well. So I'll open up the Windows menu and we'll maybe open up a notepad window. So we can now use this as a keyboard. Pretty good. But what if you wanted to run completely headless? And by headless I mean we don't have a monitor connected at all. If we're outside with the telescope, that's a very common sort of situation. You don't want to have a monitor around. Fortunately, there are tools that we can use the tablet for. We can use maybe a laptop for to connect to that. Maybe you've got a computer inside connected remotely, but maybe you're going to do a polar alignment using the PoleMaster, or maybe you're outside and just want to adjust a few things. So we can use VNC. VNC is free. I've pre-installed Tight VNC onto the Astrobar here, and I've got the app installed on my iPad as well. So we'll go ahead and close my notepad window, and we'll go into VNC Viewer. So VNC Viewer is also free, and I've set up a connection for the Astrobar. The only thing you need to do to set it up is give it an IP address. So I've put that in there and hit connect. I've currently set to an unencrypted connection. You can encrypt that connection, and I've got a password in there as well, which I'll just type in. So now what I get is the screen, a mirror of the screen on my iPad. See, everything I do on the screen is also mirrored on the monitor itself. I can open apps. I can get an on-screen keyboard as well if I wanted to type. So for example, if I do want to open Notepad again, very easy. And one of the advantages is actually we can also zoom in. So you may want to get a closer look at things that are on screen. So with this, we could turn the monitor off or disconnect the monitor completely and completely remote control the Astrobar. So very useful if you do want to use this outside in headless mode. So a couple of other things I did want to talk about. One was the serial port. Very, very useful to have hardware serial ports because USB serial ports can be all kinds of frustrating. Changing COM port numbers and reallocating settings. So having some fixed COM ports is actually a really good thing for an astronomy computer. So the cable that we get has got these really neat locking connectors. I believe they're aviation sourced. They have a red dot and you match that to there and simply push in and they lock. So that's very, very good. They're not going to pull out very easily at all. And that will plug into your mount through a standard adapter or whatever equipment you've got. So maybe a focuser or filter wheel. So that is very, very good. And the other connector that I wanted to talk about as well, which is kind of interesting, was this remote power connector. You do get a cable for this, but it just goes to a bare end. I don't know if you can make that out on the video, so you will have to strip that and connect it. It is actually the same as the Wi-Fi antenna connector in actual fact, a coaxial connector which you screw in. Now the internal connection of this actually goes to an opto isolator. What that means really is it's driving an LED. So the information is actually in the documentation that you can download on what the opto isolator is, and I'll just look that up for you. That is, so that is a TLP281 photocoupler. It's actually made by Toshiba. The connection of that is actually to an LED, and that LED drives a photo transistor. That means that whatever you drive from this isn't going to be electrically connected at all to the source in here, although this is grounded, so do be aware of that. Now I will put a link to the data sheet for that part if anybody's interested, and I'll also put a link to the documentation. Now it is kind of hard to download because it does come from a Chinese file sharing site. So what I might also do is I'll put a link to an already downloaded PDF file. That might make it a little easier. So the example that's in the manual actually just has a resistor and a switch connected to a 12-volt power supply. That will allow you to turn the power on and off for this remotely if you've got that set up outside. So quite neat and a good feature. So one thing I did want to do, and one thing I've already had some requests for, is to have a look inside this thing. So this of course is not advisable, and it would be invalidating any warranty, but it is useful to have a look inside. Also bear in mind that this is a beta test unit, so the interior look of this may not well be finalized, and I would expect there to be some changes before the final version. The casing is held together by hex head screws. I'll just get the right hex driver for that. Once again, I don't advise you doing this with your own unit. It will invalidate your warranty, and if there are any problems, then that could cause you some issues. If you do need any work done, if you do get one of these units, such as you do want to install or upgrade that internal storage, then you can return that to Astronz and we can get that work done for you. So remove the case there, and here's the inside of the unit. So the main board is over this side, and that houses the Intel processor and the Wi-Fi and display drivers. This section here is the power, so you can see that all the power is actually common together, and the I/O board with all of the USB logic is a separate board on this side. Now the TF card, if you did need to install one, is actually installed on the back of the main board, so you do actually have to take the whole main board out, and this is why I say it is not really a user task to put that in there. There is a risk of damaging the cables, there is a risk of damaging the main board as you take that out, because the board is it's not just sat there, it's screwed down and it's attached to a pad to help the thermal transfer of heat from the processor. But yeah, quite neat and compact internally. As I said, there may well be some changes to the final one, but yeah, rather a nice little unit. Now, one thing of note, and the manual does talk about this, well, two things for note in actual fact. The mounting holes that you can use to attach this to a telescope or a bracket or a mount, the threaded holes, the through holes of course go all the way from one side to the other. The threaded holes they are holes and they go to the inside of the case. The instruction manual does give safe depths for screws going in any of these holes. Now, what you obviously be able to work out is if you had a screw that's too long in there, it will interfere with the boards, particularly the ones on the back side, on the red side, because the main boards are underneath these screws. So if you were to screw too far, that is going to start to impact the board. Another thing to be aware of is this is not a device that you really want to be getting wet. So that is something to bear in mind when you deploy this, is to put it in a sheltered position, because if you do have dew forming and dew getting into the holes here, then that could cause some problems with the internal electronics. I would recommend putting that in a sheltered area, perhaps covering these holes with some tape, or perhaps even screws in there as well. I don't think it's of a major concern. Most devices that I use outside, I keep covered up anyway, so if I've got my laptop out there, that's not particularly water resistant anyway. It is something that I would certainly like to see a future version address, to make sure that it is a little bit more weatherproof. We've certainly got the right idea with some of the lock-in connectors. They are a little bit more robust and good for the elements. Of course, when we've got USB ports and LAN ports, they're obviously things that you want to keep moisture away from. So this is something that I would install in a position that isn't getting a lot of dew buildup. But other than that, it's a great little device. So I do encourage you to leave comments to this video. I do intend to do a follow-up video with software installing on here, and what software we can use and using in a real-world situation. So if there is something you'd like to see, or like me to put this through its paces, then do leave comments and I will be a follow-up video. So thank you for watching. This was the QHY Astrobar.